Good morning, guys. I'm going to record this video again because the first one had bad audio. So, the rate of change, behavior of graphs, average rate of change is simply change in output divided by change in input, and that is delta y divided by delta x, which is y2 minus y1 divided by x2 minus x1. I hope you remember that this is the formula for slope or gradient that you guys looked at a lot over 8th, 9th, and 10th grade. So the average rate of change of a function is simply the slope of the function over that interval. So an example is here. If I want to find the average rate of change between 2007 and 2009, I know that that's going to be equal to delta y divided by delta x, y2 minus y1, x2 minus x1. I can still go further and say fx2 minus fx1 divided by x2 minus x1. The value of the function for the second x value, or when the second x value being 2009, the value of the function is 2.41, and the value of the function for the first x function, that is when x is 2007, is 2.84 divided by 2009 minus 2007. So when I work that out, I hope you can confirm that I'll get a negative answer. Now that negative answer means that the price of gasoline, the price of gas, is going down. Because the rate of change is negative, it means that the output value is going down, or the function is decreasing over that domain. So that means the price of gas is going down. Estimate the average rate of this function from x is 1 to x is 4. Again, rate of change is delta y delta x, y2 minus y1 over x2 minus x1. So I need to ask myself, what's the value of the function for the second input value, and what's the value of the function for the first input value. The second input value being 4, the value of this function is, I think, 3.5, and the first input value being 1, the value of the function at 1 is 5, divided by 4 minus 1. This gives me also negative answer, which again tells me that over this interval between 1 and 4, over this interval, the function is decreasing, or that the graph is decreasing, or the output values are decreasing. Now, one thing to note is consistency while using this formula. Consistency meaning do not change it around to be y1 minus y2, because that will affect your result. That will affect whether or not you get a positive answer or a negative answer, which has meaning. Each of them has meaning. If it's negative, it means the graph is decreasing, and if it's positive, it means the function is increasing. The other thing to note is that if you look at this function, I hope you remember from 8th, 9th, and 10th grade that if I have a line that kind of looks like that, that line has a positive slope because it looks like the right hand. And if it looks like this, looking like the left hand, it has a negative slope. So if I look at a graph of a function, I can try to see whether it looks more like the right hand or whether it looks more like the left hand. If I look at this one, if I were to draw tangents to this graph at this point, right? If I draw tangents at that point, going all the way up to that turning point, we used to call them turning points, you can see that the slope is looking like this right hand right here. So it's looking like a positive slope. It has a positive slope at different points along this section of the graph. So I can say that between this point and this point, the graph is increasing, or the function is increasing. The opposite thing can be done here. If I drew tangents to this curve kind of that way, all the lines that I'm drawing that are tangent to this curve in this section between 1 and this point 3, all those lines are going to have a gradient that's kind of looking like the left hand, which means that it is negative. So in that section, the graph is decreasing, and then going back here, the tangents are going to look like the right hand, or the graph itself even looks like the right hand, so it is increasing. Now, between 1 and 4, there is more decrease than an increase. There's both an increase and a decrease, but there is more decrease than increase. That's why overall the function is increasing between 1 and 4. Average rate of change of this function, if I just substitute my values in the formula, delta y out of delta x, y2 minus y1, delta means change, so don't be wondering what I mean by delta. So if I substitute, this is x2, this is x1, substitute 4 squared minus 1 out of 4, subtract 2 squared minus 1 out of 2, divide that by 4 minus 2. You guys can go ahead and simplify this because you're pro the algebra. So that gives you, I think it's going to give you a positive answer, which tells you that that function is increasing over that specified interval. Right, let's try this one. I'm trying to find the rate of change of this function over that interval, delta y, delta x. Again, y2 minus y1 over x2 minus x1. Now remember, this definition is the value of the function for the second input value minus the value of the function for the first input value divided by the second input value minus the first input value. So the value of the function for the second input value is the value of the function when I substitute, because this is the second input value, x2, and this is x1. It's the value of the function when I substitute for x as 2 plus h. So in place of x, I'm going to put 2 plus h squared minus 2. That's y1 or fx1. And then I'm going to substitute 2 in place of x. That will be my y1. Sorry, this is y2 and this is y1. Everything divided by x2 minus x1. If I simplify this, which is 3 open brackets, 2 squared is 4 plus 2h. This is just expanding. You can do this slower on your own. Minus 2 minus 3 times 4 is 12. 12 minus 2 is 10. So that's negative 10. Everything divided by 2 plus h minus h. The positive and negative to cancel, so I'm only left with h. Simplifying that, if the 3 goes inside these parentheses, I'll have 12 plus 6h plus 3h squared. Everything divided by, minus 12. Everything divided by h. The positive and negative 12 cancel out, and I'm left with 6h plus 3h squared. Everything over h. If I simplify that, I will have, because h is common, I can factor out h into 6 plus 3h. Everything divided by h. And if I simplify that, it's plus 3h. I can still write it as 3 into 2 plus h. Yeah. Okay, moving on. Increasing or decreasing. So I talked about this a little bit earlier. If the value of a function, if the y values of the function are going up as you move to the right across the domain, if the values of y are going up, because every time we're looking at where the function is increasing or decreasing, we'll be going to the right across the graph, to the right across the domain. So from the smallest values of the domain to the larger values. So as I'm moving to the right, I need to check, are the y values increasing or decreasing? Are the values of the function increasing or decreasing? So if I look at this, as I go to the right, the values of the function, like around here, 20, then as I move to the right and go to this position, the value of the function is now 18. Move to the right, now this position, that's negative 2, the value of the function is 16. So if what's happening is, these values of the function are going up as I'm moving to the right. And if that's happening, the function is increasing. The opposite is happening where, as you move to the right, so if I continue to move to the right, the value of the function changes from 16, now it's 12, right? And if I continue to move to the right, now I'm at this position, it's changed from 12 to 0 now. And if I move to this position, it's changed to negative 8. So what's happening is the values of the function are going down as I'm still moving to the right across the function. That means the function is decreasing, and then it starts increasing again back there. Yeah. Alright, so this is what this definition is telling us, that a function is increasing on an open interval where all the values of the function for an input value b are greater than the values of the function for input value a, only and only if b is greater than a. So what it means is that if around here is b and this is a, then I expect the value of the function at b to be greater than the value of the function at a for me to say that that function is increasing, which is simply what I explained a little bit earlier. The same thing for decreasing. If the values of the function are going down as we go to the right across the domain, then the function is decreasing. Now, there are some points you have seen on these graphs. These points that in 8th, 9th, and 10th grade we used to call turning points. Here we're going to call them local extrema. Local extrema. That's like a plural form of turning points, I think in Italian. I don't know. So local extrema, this one is called the local maximum, and this one is called the local minimum. The local maximum is the point where the curve changes from being an increasing function to a decreasing function. Or if you look at it closely, since this is kind of a straight line, like I can draw a tangent there and I can also draw a tangent here. The slope of the function, or the gradient of the function, is changing from being a positive gradient to being a negative gradient, changing from right hand to being left hand. Because I know that at the very top, the gradient will be 0, right? So it's changing from right to left. That's how you know that that's the local maximum. And if the opposite is happening, where it's changing from left hand and going to right hand, then you know that that's going to be the local minimum. So the local maximum for this graph is happening at that point where x is 2 and y is 16. The local minimum is happening, happening where x is -2 and y is -16. This curve is increasing over the interval from, because of this arrow, from -infinity all the way up to 2. 2 is not included because I know that at the very peak, the gradient of the function, or the slope of the function, is 0, right? So it's neither increasing nor decreasing at the very top. Same thing at the very bottom, neither increasing or decreasing. So that's why the 2, which that point corresponds to 2, -2 and 2 on the axis, -2 and 2 on the axis, that point is not included because at that exact point it's neither increasing nor decreasing. So increasing is over the interval from -infinity to -2, and also over the interval from 2, again not included, to positive infinity. And it's decreasing over the interval from -2 to 2. It's constant when x is -2, and it's constant when x is 2. If you want, you can write these as -2, -2, and 2, 2. Alright. Find the local maximum and local minimum by just looking at the graph. You can see that the local maximum is this point right here, where x is -2, y is 16, and the local minimum is previous question, 216 negative. Yeah, it's increasing, decreasing. This is the same question we did before, so the same ranges of the domain, the same values of the domain over which it's increasing and decreasing. Alright, now we have another function here that we need to find a region for which it's increasing, decreasing, or constant. This region from -infinity up to 1, it looks more like the left hand. If you put your left hand up, it looks like that region. So I know that that's going to be a decreasing region. That's from negative infinity to 1. Right, do I have any other decreasing region? Any other left-hand looking region? Right here. Yeah, so that's from 3 to 4, not included. I don't see any other decreasing region. Increasing right-handish looking region is right there. So that's between 1 and 3. And also right-handish looking region is from 4 to positive infinity. The graph is constant at x equals 1, x equals 3, and x equals 4. Remember, you can write this here as 1, 1, 3, 3, using interval notation, and 4, 4. Okay, moving on. Right, maximum and absolute minimum. The absolute maximum of the graph of a function is the value of a function that is greater than all other values of the function in the same domain. So this value y equals 2, according to how this graph is graphed, is the highest value of the function that it can have, and therefore it's its absolute maximum. Same thing goes for that. That's the absolute minimum because it's the lowest value that that function can have in that domain that's graphed. Now, you should note that not every graph or not every function will have an absolute maximum or minimum, and just to demonstrate that here, this function continues endlessly in the positive y direction, so there's no way of knowing what its absolute maximum will have. According to the region that we see graphed, it does have an absolute minimum, but we can see clearly that it won't have an absolute maximum. It will just keep going to infinity. That's just what that was specifying. So yeah, the absolute maximum, this is the definition of a function f at an input value c is f of c, f of the input value c, where that value of that function is greater than all other values of the function in the same domain of f. The absolute minimum, same definition, the value that's smaller than all other values of that function in that domain. Alright, for this function shown, we can see that the absolute maximum is f of 2, because it happens when x is negative 2, so f of negative 2, and it also happens when x is 3 and 16, and the absolute minimum is happening again when x is 3, and that's negative 10-ish, I think. Alright, so there you go. I hope you enjoy your homework. Now, a couple of days ago, there was a column on your parent graph page that I told you to ignore, but today is the day you get to finish it. So you're going to go to that page and then write on these functions whether they're increasing or decreasing, and over what domain, over what values of the domain they are increasing or decreasing. So yeah, that's what I want you to do. Just go and then write whether it's increasing, decreasing, and over what domain, what values of the domain is increasing, decreasing, and where it has absolute maximum, absolute minimum if it does have, or the local maxima and local minima.